All right, so we're going to finish up looking at law of sines today by looking at that last case, okay, where you can get the two solutions or no solution. Okay, so just a reminder of what the law of sines is, okay, in case you forgot. So I consider it, each fraction is like a separate part, and when you use the law of sines, how many parts do you use at once? Only two. Okay, any two parts, okay, but only two at a time. Okay, what's the case with law of sines where you have to be careful for the two solution, one solution, and no solution? What are the letters for that?
SSA.
Yep, SSA. Okay, so anytime we've got side-side angle, that's the only case out of everything we studied yesterday, today, and what we do tomorrow. It's the only case you have to be careful with. Everything else is always going to have one solution. Now, there's two ways to tell if you have a SSA problem. One, you can draw the picture, okay, and see where the information is that you're given. Or if you set up a table like this, you can tell just by looking at the table. So my next question is, how can you tell by looking at the table if this is side-side angle? Yeah.
All right, quick question. You said that could have two solutions, right? The side-side angle?
Yeah, this one can have 0, 1, or 2 solutions. We already did the one solution. Okay, that was yesterday. Yeah.
Because you have a row that has nothing in it.
Okay, we have a row with nothing in it. And what else? What tells me that it's law of sines?
You have a row with everything in it.
Yeah, we have a row with everything. Anytime you've got a row with everything, that tells you that it's law of sines. Then if you look a little closer and notice a row with nothing in it, and there's no way to get anything in that row directly, that's the case that you got to deal with 0, 1, or 2 solutions. All right, so Selena, what do I have to find first out of the 3 boxes? Which one?
Beta.
Yeah, we got to do beta first. Okay, because at least I've got something in that row that can help me. Okay, so we'll set up our law of sines and see what happens. Okay, so Jake, can you tell me what row, besides the second row, because we're going to use that to find beta, what other row do I have to use? First row, and how would I plug that into my formula?
6 sine of
Okay, what's going to go on the bottom? If we go back, let's see if do we have one. I closed the homework, but Tyler, can you help him out? What goes on the bottom here?
Sine of what's the sine of 35?
So I like the sine of 35, but that doesn't go on the bottom.
So 6 doesn't matter.
Let's go back and just, sine's always in the top. Yeah, the 6 is going to be in the bottom. Okay, so sine of your angle goes in the top, length of the side in the bottom. So sine 35 in the top, 6 in the bottom. Okay, so now that we got the left side set up, could you tell me, Jake, what's going to go on the right? And I'm going to use row 2. So the bottom is 8, and what's in the top? Sine of beta. Okay. So now our goal, we're going to solve it, cross multiply, and try to get beta by itself. Okay, if in this case, because the variable is in the top, all I really have to do is multiply by 8 and multiply by 8. Okay, if you want to cross multiply, you can, but you don't need to be that complicated with this problem. So 8 sine 35 over 6 equals sine beta. How about Eden? What do I do next?
So then you just take the inverse of sine on both sides.
Yep, I'm going to take the inverse sine on both sides. And Joey, what's that going to do on the right side? what's taking the inverse sine of what we already had going to cause to happen?
It's gonna cancel out the sign.
Yeah, that's the whole reason why we did it. Right? We want to cancel out that sign. And now, Francis, what do I have left on the right?
Just beta.
Just beta. And now we got to do what's on the left.
Does, like, once you set it up like that and you do the cross multiplying, does the sign always go outside if it's like the beta or the, like any of those three things? Like it doesn't stay in the denominator?
Like this inverse sign being on the outside, or no?
No, when you equal it to sine beta,
Mhm.
the sign never stays with the 6 in the denominator? It always
Right,
goes
yeah,
out.
the sign is always with the 35 or with the beta.
Okay.
It's, yeah, you'd never put the sign with the 6. Yep. All right, so now once we type in what's on the left, we're about to find out if it's a no solution or at least one solution. All right, so we'll type it in. Do second inverse sine, 8 sine 35. Now before I continue, what do I have to be careful of right now?
Losing the frequency.
Yeah, if I forget, it's going to mess it up. All right, so is this a no solution? What do you think, Shannon? No, I just got a solution right there. Okay, 49.886. Okay, that's definitely at least one solution for beta. Okay, so write it down, and I would put it a little higher in that box. And Megan, do you remember what you do with that number, what you subtract it from, to see if there's a second solution? I'm sure Travis can help her out.
You subtract from 180.
Subtract it from 180. Okay, so if there's a second solution, you take 180, subtract 49.886, and that would be the second solution. Okay, it's just a question of if that works. And by works, I mean, does it all fit in the same triangle? So, Alex, what angle was I given to start?
35.
I was given a 35. Can I fit a 35-degree angle and a 130-degree angle in the same triangle? Yep, that only adds up to 165.114. So this time, the second answer does work. Okay, so we're going to take that answer. And we'll put it right there. And now what I'll do is, because I have two angles for beta, I'll call the first one beta 1. And I'll call the second one beta 2. Now, if I have a beta 1 and a beta 2, what do you think is going to happen with gamma?
It's going to be 1 and 2.
It's going to be a gamma 1 and a gamma 2. And what about for C? A C1 and a C2. Okay, so now what we're doing from here is we're really solving two problems at the same time. If you want to make two separate tables, you could. I think it might be more confusing to make two separate tables. So I'm just going to use one table. Okay, I'm going to put a box around the three angles that make up one of my two triangles. That angle is in one triangle. So is that angle. And so is that angle. Those three boxes in blue make up the three angles in one of my triangles. Okay, so how would I get gamma 1? What two numbers do I have to add up?
The 35 and the 49.886.
Yep, those are the only two that have anything to do with gamma 1. 35 and the 49.886. Okay, so I get 84.886, and then subtract it from 180. Okay, so to make the three boxes in blue add up to 180, gamma 1 has to be 95.114. Okay. Any question on how I got gamma 1? Now what I'm going to do is, in a different color, I'm going to put the three angles that make up the other triangle. There's this angle, and this angle. So notice alpha is used twice. Okay, that's in both. But then we have alpha, beta 2, and gamma 2. That's my second triangle. So Andy, what two angles would I have to add up this time to get gamma 2?
The given and one you have in red.
Yep, the given and what other one?
The one in red now.
Yep, and what's that one called? Beta 2. So the given and beta 2 add up to 165.114. Subtract it from 180. And I get gamma 2 is 14.886. Now that I have the angle that's across from C1 and the angle across from C2, I can find C1 and C2. Cody, what angle do you think I'm going to use to find C2? Gamma 1 or gamma 2? Yeah, gamma 2 is going to find C2. And Canessa, what angle will I use to find C1?
B1 and like B1 and gamma 1.
Gamma 1.
Yeah.
Okay, so to find C1, we use gamma 1. Now, in addition to what I just said, there's another row here that's going to be used twice. Max, what row is very important, and I'm going to use it to find C1, and I'm going to use it to find C2? Yeah, the top row. This row is in both triangles. Okay, A and alpha is in both. So let's start by finding C1. Okay, so Corey, can you help me to set up my proportion to find C1?
Yeah.
What could I start off with?
You're gonna put B on the bottom of your first proportion. You're gonna put 8 on the bottom of your first fraction and then sine 49 on the top. 49
All right, so you could use this middle row, which is actually two rows. Like these two numbers make up a row,
Yeah.
and these two numbers make up another row. But there's a reason I'm probably not going to use that row, but I like the top row better that Max said.
Okay.
Why do you think I like the top row better?
Because we're doing math for it.
Yeah, these were given, so they're exact. Okay, it's not wrong. You could use the second row. It's just you're going to have to deal with all those decimals. I mean, we're still going to have to deal with decimals, but at least if we use the top row, it's a little less.
So you do sine 35 degrees over 6.
Yep. Sine 35 over 6. And in fact, when I find C2, we're going to start the same way. So I'll write it right now. Sine 35 over 6. And Corey, could you just finish up for me how to find C1?
Yep. You put gamma at the top, sine of 95.114 degrees.
Sine 95.114. Yep. And you're going to divide by
C1.
C1. And now to set it up for C2, you're going to do the same idea, except use gamma 2. Sine 14.886. Over C2. Okay, and now we just solve each one exactly the same way. Okay, cross multiply. And C1 is going to equal 6 sine 95. 0.114. Okay, divided by sine 35. Okay, if somebody has a calculator and can type that in, I'll set it up for C2. And then hopefully when I'm done that, somebody will have C1. All right, so C2, cross multiply the same way. 6 sine 14.886. And then divide by sine 35. And that's C2. All right, so anybody type in C1 and get that? Yeah.
I got 10.419.
10.419. Anybody else get that? You got that? Okay. seems reasonable. In the blue triangle, gamma 1 is the biggest angle. So C1 should be the biggest side, and it is. All right, and how about for C2? Yeah, Travis?
2.687.
2.687. Okay, so that's a pretty small side, but gamma 2 is a pretty small angle. So smallest angle should be with the smallest side, and gamma 2 is the smallest of the red boxes. So that's it. So that's a two-solution case. So that one we just did, that's as hard as they get.
Can you go back onto your work for C2?
Okay, any questions on how we got to C1 or C2? All right, so what I'll do before we look at the last one, which is a no solution, okay, I'm going to try to draw out a triangle that has two solutions. Okay, I'm going to try to draw it exact, okay, using the smartboard and measuring things. Okay, and I'll show you how you can take two sides and an angle, keep them the same, and draw two different triangles. Okay, so I'm going to take this triangle. I'm going to copy two of the sides and one of the angles, but I'm going to draw a totally different triangle. Okay, so I'm going to start by making a copy of that side. Okay. Does everybody agree that that side and that side are the same? Now I'm going to take a copy of the right side, but I'm going to do one extra thing. I'm going to make a mirror image of it. Now, does reflecting something change the length of it?
No.
No, it's still the same length. I just mirror imaged it. Okay, I'm going to put that right there. Okay, so now that side is the same as that side. And the last thing I'm going to do is just connect my third side. That's all I have left. Okay, so that's my third side. Just put it down a little. And I'm going to group everything together so I can move this triangle up and show you what angle I kept exactly the same. Okay. Bless you. Okay. Angle in the lower left, it's exactly the same in both triangles. Does everybody agree with that? So what I just did is I drew two different triangles, but I kept two sides and an angle the same in each. This is the only type I can do that with. If you gave me anything else, like if you gave me side angle side or angle angle side, I couldn't do what I just did. Okay, so visually that's how you can get two different solutions. And what I just drew is basically what just happened in this problem. Okay, so any questions on that? All right. So the last one we're going to look at, we'll do the same thing. We're going to solve a problem, and then we'll try to sketch it. But when you try to sketch something that has a no solution, that's a little more interesting. We'll see what happens. Okay, so just by looking at it, you wouldn't know that there's no solution. Okay, unless you're really, really good with numbers and you know roughly what the sine of 50 is in your head and what you get if you double it. But we'll just go through it, solve it, and start to see what happens. So Alex, what do I have to find first?
Alpha.
Yeah, I've got to do alpha first because it's got something in the row that can help me. I got to ignore the middle row. Can't do anything with it right now. So sine of 50 over 1 equals sine of alpha over 2. All right, so in this one, this is an example where, you don't really need to cross multiply because this is just a denominator of 1. So what I would do is just multiply by 2 on the right, multiply by 2 on the left. And that's all you got to do to get sine alpha by itself. Right, and Gilly, what do I do now to get rid of sine?
You divide it by, divide it, having a memory lapse right now. Divide it by sine 50.
So the sine 50, we're going to leave that where it is because that's on the left. What I'm trying to get rid of is something that's on the right.
Okay.
So anyone help him out? What do we have to do to get rid of that sign? I'll give you a hint. We can't divide by sign because it's a word. It's a function. So we need another function that cancels out the sine function.
Inverse sine.
Inverse sine. Okay, so we're going to take the inverse sine of everything on the right. That's gone. Take the inverse sine of everything that's on the left. Okay, so this is what we need to type in. Let's start just by, for a second, I just want to show you what 2 sine 50 is. I got 1.53. Now, if you were to graph sine, okay, like we did last week, what's the highest that sine normally goes? 1. It only goes to 1. It doesn't go to 1.53. So, if you try to type in the whole thing, inverse sine of 2 sine 50, it gives you an error. Okay, what you're basically trying to do, if you want to think about it visually, here's 2 sine 50. Okay, that's about 1.53. And here's the graph of sine. Okay, what I am asking is where those two graphs cross. That's what you're trying to do when you type this in. Okay, where do they cross?
Well, they don't.
They don't. That's why when we typed it in, we got an error. Okay, we couldn't solve it. Okay, so since we try to type that in, we get an error. Whatever your calculator says, it might say something a little different, but you're not going to get an answer. So we can't solve for alpha. Okay, so no solution. Now, if you can't get alpha, what other angle can't we get?
Beta.
We can't get beta because we have nothing to add to the gamma and then subtract from 180. And if you can't get beta, you can't get the side across from it, which is B. Can't get that either. Okay, so the nice thing about no solution is you realize pretty quickly you can't find anything. Okay, so I'm going to try to draw this. Obviously, I can't draw it, because if I could, I would have gotten a solution. But does anybody know what's going to happen when I try to draw it? What it might look like? It's still going to have 3 line segments, but what do you think is going to happen if it's not going to be a triangle? Well, we'll sketch it. Let's see what happens. Okay, so I need to sketch one side that's twice as long as the other. Doesn't matter if I use inches or feet, but just make one side twice as many units as the other. Okay, so what I'm going to do is draw that, and then I need something twice as long. So now that is twice as long. Actually, I don't need a copy of it. Let's just group it together. Okay, so the top side, the bottom one is A, the top one is C. Now, the other thing that has to happen is I have to have a 50-degree angle. Okay, so what I did is I just used my protractor, which you can basically draw any angle, and it'll sketch it for you. So I'm using that to set this line at a 50-degree angle. Okay, so I'm just going to go over here and roughly put that at a 50-degree angle. Now I can't change the length of that, and I can't twist it. If I twist it, it's not going to be at a 50-degree angle to the horizontal. Okay, so keep that just the way it is. Okay, the bottom side is side B, and the side that's 1 unit long, this is side C. Okay, so I'm going to put it on the end. Now I can turn that any way I want. Okay, they didn't specify any other angles, so this doesn't matter what this angle is. Problem is I can't turn it unless I group it with something on the smartboard and then erase it. I don't know why, but now I can turn it. Okay, so that's side C. Now side B can be as long as you want, or short, but it has to stay horizontal, otherwise you wouldn't keep it at a 50-degree angle. All right, so here's side B. Okay, so what happened there? Yeah, the sides don't connect. Now, if I rotate this angle, maybe if I go like this, put it like that, and I make this shorter, will they ever connect?
Never.
No. Okay. In order for these sides to connect, you'd have to change one of two things. Either one, change this angle, maybe make it smaller, or make this other side longer. Okay. But I can't do either one of those things because that's what they told me. I have to keep it 1 unit long, and I got to keep it at 50 degrees. Okay, so that's what happens when you try to draw a triangle that doesn't exist. Okay, the sides don't connect. Okay, so any question on the no solution case? All right, so the last two we're going to look at are both word problems. You don't need to copy down the whole problem. It is in your book. Okay, but if you do want to write something down, all you really do is write down the important numbers. All right, so what's going to happen in this problem, just kind of the background, is a surveyor is going to measure the height of a mountain. Okay, and what we're going to do would work for a mountain, a building, anything. Okay, and the way the surveyor is going to measure the height, they don't have to know how far away they are from the mountain, okay, which is helpful. And they really don't have to know anything. All they have to know is, all they need is an instrument called a transit. Okay, anybody know what a transit is?
That looks at something and gives you the angle.
Yeah, it's like if you see sometimes on the side of the road people looking through like a device that's on a tripod, and sometimes there's another one further down. A lot of times they're shooting like a laser from one tripod to the other, just to measure either how far apart, or they can also measure like the pitch of the road. They use it on property to make sure water drains away from the house. So it's basically just something that can measure an angle. So what this surveyor is going to do is take two sightings 900 meters apart. Okay, so they're going to stand in one spot, set up the tripod, shoot a laser to the top of the mountain, and it's going to tell them the angle to the top of the mountain. Okay, then the surveyor will get in their car, drive 900 meters back, and set up the tripod and measure the angle again. And just by measuring those two things, you know the height of the mountain. Okay, or the computer on the tripod would be able to tell you. So the first time that the surveyor measures the angle, okay, it's 47 degrees. Okay, so angle of elevation was like if you were, eye level with the ground, the angle you'd have to look up at to be staring right at the very peak of the mountain. Now, as the surveyor backs up 900 meters, what's going to happen to this angle? It's going to decrease, right? Think about if you're looking at like a screen, right, at the movie theater. If you're like right in the first row, you're looking up very steep. As you go back from the object you're looking at, you don't have to look up as steep. Okay, so the second time, the surveyor gets an angle of 35 degrees. So really, you could just write first observation equals 47 degrees, second observation equals 35 degrees. That would summarize all that. And the other thing I'm going to assume, just to take one level of complexity out of the problem, is that the transit is level with the ground. Okay? Most of the time it's not true. It's on a tripod. But if I assume it's on a tripod, then I need to know the height of the tripod. So just assume that it's on the ground. All right. So in this problem, there's just a ton of words, a lot of numbers. What do you think would make this information a lot easier to understand?
Drawing a picture.
Yeah, let's make a picture of all that, and we can say all this in a lot less words. Okay. So the first thing I need is the ground. And besides the ground, what other very important feature do we need? We need a mountain. So let's just put a mountain. There's a mountain. There's a steep section in there, so you gotta be careful when you're climbing that.
It's like inverted.
Yeah, so we got
Double black eye.
our mountain. And now the surveyor is going to stand at 2 points. Okay, we don't know how far he is from the mountain, but we do know how far apart the two sightings are. How far apart are the two sightings? 900 meters. From here to here. Okay, and the first time, the surveyor is going to measure the angle to the top of the mountain. And I'm going to put that as a dotted line. Okay, and the first time that he measures the angle, what does he get?
47.
47. Okay, then the surveyor backs up 900 meters and does the same thing again. Measures the angle to the top of the mountain. Okay, and I'll put that as a dotted line. At the second time, he gets an angle of, 35. Okay, so those two measurements, knowing how far apart his two sightings are and the two angles, that's all you need to find the height of the mountain. Okay, so this is the height of the mountain. And I'll put that, just put that in red. That's what I really want to know. So eventually what I'd like to be able to do is just work with this triangle that I'm drawing in green. Why is this a nice triangle to work with?
Because it's a right triangle.
Right, because it's a right triangle. Okay, so that's what I'd like to work with. The problem is I don't really know enough information. All I know is this is 47 degrees. And I know this is 90. But the problem is I don't know any sides in that triangle. So I can't use it right away. But there is a side that is shared between the triangle that's formed by the dotted lines and that green triangle I just drew. Okay. This side is shared between them. And I've got enough information that I think I can work with this triangle right here. All right, so I want to focus first on this angle right here. Knowing the one next to it, anybody know how I can find the one that's inside?
Subtract 47 from 180.
Yeah, just subtract 47 from 180. Okay, so now I know this angle is 133. So forget about the 47. We're not going to come back to that until we look at the right triangle. Okay, I want to use the law of sines, but the problem is to use that, you need to know an angle and you need to know a side across from it. Right now I have an angle, but I don't know what's across from it. I have another angle, and I don't know what's across from it. And I've got a side, but I don't know the angle across from it. So there's one more thing I need to find out here.
Find the other angle.
Yeah, how can I get this angle right there?
Add 35 and 133 and subtract it from 180.
Yep, take 35 and 133. Add those up, subtract from 180. And you get this is 12 degrees. Now I've got an angle and what's across from it. Okay, so now what I can do is I'm going to set up my law of sines. And I'm going to try to find that side right there, which is that side right there. Okay, because if I can figure out what x is in this dotted triangle, then I can figure out what h is in that other triangle. Okay, but I have to find x first. Right, so what would I put on the left side? Sine of what angle divided by what side?
12 and 900 together?
Which one goes with sine?
12.
Yeah, 12. And in the bottom?
900.
Perfect. Now just go on the other side, and you got to use the angle across from the side. So sine of 35 over x. If you don't like using x, you could use a, b, or c. You know, those are the letters we normally use. But. Okay, so cross multiply. X is 900 sine 35 over sine 12. Okay, and I'm going to round that off. Okay, since it's the height of a mountain, most mountains are just rounded to the nearest foot or the nearest meter. But I'll keep 2 decimal places for now, and then when I'm done, I'll probably just round to 1 decimal. All right, so 900 sine 35 divided by sine 12. Okay, so is that the height of my mountain?
No.
No. Okay, but it's an important number that we're going to use. 2,482.88. I'm just going to put it up where my picture is so I know what it is. 2482.88.
So is there a way to like subtract the difference in the real world from the tripod?
Is there what?
Do they like subtract the difference from the tripod?
So if you were doing this like in the real world and finding the height, here's your tripod, here's your transit on top of it. Basically, here's your mountain.
After you're all done, just add that like 3 feet.
Yeah, just add the height of the tripod to the height you found from the tripod up. That's all you'd have to do.
Yeah.
It's not that hard, but
Yeah.
just not the focus for what we're doing. All right, so any questions on how I got the 2,482.88? Yeah. All right, so I'm going to erase that because now I know the number. So I found this side in green, which is really the what of this other triangle. It's the hypotenuse. Okay. And what kind of triangle did we say this was earlier?
Right.
It's a right triangle. Okay. So using 47 as your reference point, what's the name of the side that's farthest away? Opposite, adjacent, or hypotenuse?
Opposite.
So we've got opposite. And you guys just told me the side across from the 90. That's the hypotenuse. So what trig function can we use to find the height? Sine. Just a coincidence that we're doing law of sines and you're also using sine. Could have been cosine or tangent. Okay. Now I'm going to set up my formula and I'll put it right next to my diagram. Sine 47 equals, what side is opposite?
H.
H, and what's the hypotenuse?
2,482.88.
Yeah, so I'm just going to need a little more space. 2,482.88. So what would be my last step to get H by itself?
Multiply.
Yeah, multiply each side by 2,482.88, and that'll put it on the other side, and you'll have H by itself. So 2482.88 sine 47. Multiply that out, and that is the height of the mountain. Okay, there's a lot of shortcuts we could have used here. Once you've done several of these problems, you don't need to go through every step we've done here every time. Right? You can kind of just, for the final answer, you can already see where that angle is coming from. It's just that angle right there. All you have to do is come up with a shortcut for how to get this. And you could save yourself a lot of time. But we're not going to do another one like this. So. All right, so 2,482.88 sine 47. So our mountain is 1,815.9 meters.
Would that not be considered a mountain?
Well, that's pretty tall. I mean, that's in meters.
Oh, yeah.
So roughly, if you triple it and then add a little more, that's what it would be in feet. So not as tall as Mount Washington, but certainly a lot taller than Mount Monadnock, if you know that one. So it's a pretty decent mountain. Compared to mountains out west, though, like in Colorado or like in Alaska, that's a baby mountain. Yeah.
Bigger than what you said.
What's that?
Bigger than what you said.
Oh yeah, much bigger. Yes, much bigger than that. What you did.
What you said.
All right. So any questions on that one? All right. So I think it's probably a good place to stop for today. All right. So the homework tonight is on 267, same page as last night. 29 to 35 odd, and 39 and 43. Okay, so some of these problems, as you solve them, they're going to be the two solutions. Some are no solution. And then I think the last two are word problems. Okay, so tomorrow we should be able to finish everything for the week, and that means we'll have a review day on Thursday, and then last test on Friday. Okay, remember, if you do owe me anything, make sure you make it up before Friday, because that's when grades close.